Hello, geometry students. We're in section 12-6, and we have some new vocabulary. We have great circle. We'll find out what that is here in a little bit. We also have pole, and we have hemisphere. Okay, so here's a key concept. Surface area of a sphere. The surface area of a sphere has an equation which is 4 pi r squared. So we can think of this as the area of a circle, which we already know is pi r squared, and just multiply by 4. So here's our first example. So in this problem, we're going to use 4 pi r squared, where the r is simply 4.5. We're going to stick it in there, and we're going to square it. And then multiply by 4 pi. We use our calculator, round to nearest tenth, and then make sure we have inches squared as my unit. Okay, here's a problem for you to try. Pause your video and try to find the surface area. Good. You got an answer of 490.9. You did it right. Okay, next example. Use a great circle to find the surface area. Well, the great circle is actually, you can see the large circle here. Okay, and I'm highlighting all this right here. That's called the great circle. And that's actually right at kind of like the equator. But we actually have an area there. So the surface area of a hemisphere is half of a sphere, first of all. And then the bottom part is exposed. So that's a circle, so we're going to add pi r squared. In this case, we're just putting in a 3.7 into two spots, into that r and in this r. So finding half the area of the sphere with a radius of 3.7 millimeters. And then we're going to add the area of the great circle. Using our calculator, 129 millimeters squared. Okay. Now, on this problem, we're going to find the surface area if we know that the circumference of the great circle is 10 pi feet. So we already know that circumference also can be written as 2 pi r. So we can solve for the radius by dividing both sides by 2 pi, which leaves me at 5. So the radius is 5 feet. So let's come over here and label this 5 feet. And now that we know that the radius is 5 feet, we simply have 4 pi r squared, where r is 5. It looks like 100 pi would be the answer. So putting our 5 in, we get 100 pi, or 314.2 using our calculator. And make sure that we say feet squared because we are in feet. Okay, now, in the next problem, we're finding the surface area if the area of the great circle is 220 square meters. Okay, so we know that the area of a circle is pi r squared. So we're going to divide both sides by pi. And then take a square root. So in this case, our radius is the square root of 220 over pi. Or just r squared equals 220 over pi itself. You can see why we might not even need to do this, because we want 4 pi r squared. So we're going to take our 4, we're going to have our pi, and we know my r squared is 220 over pi. So it looks like we have a little cancellation, and we're going to get 880. So in this case, it looks like we can just multiply by 4. Let's see what happens. Okay. Now, I think they approximated, obviously. So when they did this, they solved an approximation of the radius where we use an exact r squared equals 220 over pi. So our answer was actually a little bit better. Okay, find the surface area of the hemisphere. Go ahead and pause your video. If you got B, you did it right. Now let's check how. Now remember, we're going to do 1/2 pi, 1/2 4 pi r squared plus pi r squared. If you want to think of this, this actually is just 2 pi r squared plus pi r squared. So the formula can actually be written as 3 pi r squared. And let's take that and put 3 pi and then take 4.2 and square it. So 4.2 squared, and multiply that by 3 pi. And I get an answer of 166.25 or 166.3. So you can actually, if you want to, you could use 3 pi r squared as your new formula for a hemisphere. That actually includes then that area of the great circle. Why can I say 3 pi r squared? Because half of 4 pi r squared, this part reduces just to 2 pi r squared. And we're taking 2 pi r squared and we're adding 1 pi r squared, which gives us then 3 pi r squared. Alright, check your progress. Go ahead and pause your video to find the surface area. (201.1 feet squared. Okay, and remember, we need 4 pi r squared for the surface area of a sphere. We know the circumference is 8 pi, but we also know that circumference is 2 pi r. I'm going to divide both sides by 2 pi, and that gives me my r is 4. So I'm going to take r is 4 and stick it in for here, and 4 squared 16 times 4, that gives me 64 pi. If we take 64 and we multiply by pi, we get an answer of 201.06, which does round to 201.1. All right. Excuse me. Here's another. I just swallowed wrong. All right. This Nachos Bel Grande went down wrong. All right. Next problem. Go ahead and pause your video. Find the surface area. (640 feet) is the answer. All right, now we're going to find the volume of a sphere. Okay, the volume is cubic unit. That's why it's r cubed. 4/3 pi r cubed is the volume of the sphere given a radius. Okay. Example number 3. Find the volume with a great circle circumference of 30 pi. Okay, so we know we're going to use 4/3 pi r cubed. We just got to figure out what r is. But we know that 30 pi equals 2 pi r. Divide both sides by 2 pi. And we get 15. So we're going to put 15 in for my r. Right. All right. And then in the next example, we're trying to find the volume of a hemisphere. The diameter of 6 feet. Well, the volume of a sphere is 4/3 pi r cubed. Hemisphere would be exactly half of that, which would be 2/3 pi r cubed. My diameter is 6, therefore my radius is 3. So I'm just going to put a 3 in for my r and get 27. 27 divided by 3 is 9. 9 times 2 is 18. How about 18 times pi? That's my answer. So somewhere around 55. Let's see what they got. Yep, a little bit over 55, 56.